Good afternoon from London. Great to see you all again. If you haven't tuned in before, I'm Kalen, and today I'm here with Andrew Betts.
Hello.
And we are part of the developer experience team here at Fastly. So what do Andrew and I do on the developer experience team? Well, we produce content, including the live stream that you're watching right now, as well as blog posts, code examples, and tutorials, which live on our award-winning developer hub. We also organize community meetups and events, and we speak at conferences. We create and maintain the tools that are used to interact with Computer Edge, and we build libraries that run on Computer Edge. But what actually is Computer Edge? Well, Fastly started as a content delivery network years ago to speed up websites. And over the years, it's evolved into a security provider also, so we can protect them. Our latest platform is Computer Edge, which allows you to go a step further and make your websites dynamic by modifying requests and responses close to the user. It's a platform that allows you to run WebAssembly natively and close to your users, which has huge performance and security advantages. And the killer feature is that you can use any programming language that you're comfortable with, providing that it can compile to WebAssembly. So what can you do with Computer Edge? Well, today, Andrew is going to be walking us through fronting a static bucket or a web server full of HTML pages and assets and turning it into a functional website with a great user experience. If you're interested in learning more about developing on the edge, make sure to subscribe to the channel by clicking the button below, because we'll be going live monthly with a variety of demos and tutorials. So without further ado, Andrew, over to you.
Okay, thanks, Kevin. So this is a little website that we put together, and you can see from the URL here that I'm accessing this page on an address exposed by Google Cloud Storage, which is part of Google Cloud Platform. And it is a very popular place for storing assets, HTML, images, things that you want to use on your website. So we want to create a scalable website with global availability and great performance at the edge that is backed by this content store. And that's what we're going to do today. And I'm going to cover a bunch of things that you can do to improve the experience of using a static bucket store like GCS or S3 with a Fastly service. So to get started, I will head over to VS Code. And the first thing I'm going to do is type Fastly compute in it and go through this little wizard. Now, if you don't have the Fastly CLI, you can go to developer.fastly.com and follow the instructions there. You can download it, install it, generate an API key, and sign in. I've already done all of those things, so I will accept the defaults for some of these things. And the first important question is, what language am I going to write my my code in? Now, we have official support for Rust, JavaScript, and Go. But you can, of course, write, as Kalen said, you can write in any language you like, as long as it compiles to WebAssembly and you can create your own SDK. So we do have an open ecosystem, and we actually have a number of community SDKs that people have created for Computer Edge. I'm going to use our official JavaScript SDK. And also, it will ask me to choose a starter kit, which is the template that I want to use to bootstrap my project. I'm going to use the empty starter, choose number 2. So this will clone the project into my local directory and give me a single source file and some metadata here. First thing I need to do now is do an npm install, because this is a JavaScript project, so I'm going to need to install the dependencies. The Fastly CLI doesn't do that for you because it doesn't make any assumptions about the fact that you're using npm, but I'm going to use npm myself. And now we can look at some of this metadata. So the Fastly TOML file is the data that's kind of proprietary to defining this project as a Fastly service. And you can see it has all the data that I gave the CLI when I set up the project. And the only thing I want to add to this is to define where my Google Cloud Storage backend is. I can do this by creating a local server section in the Fastly TOML file, which will allow me to run my project locally on my own computer. I don't have to deploy it to Fastly to see the effect of running my code. And I can create all of these additional platform resources in this local server section. I'm going to head back over to my browser and open the Developer Hub and show you where to find that. So if we go into Reference, Computer Edge Platform, Fastly TOML, and then into Local Server, this is the data model for the FOSSI file. And if I scroll down a little bit, you'll see there's a section on backends. So I want to do something like this. I'm just going to copy and paste it because I'm lazy. I actually only need one backend. And I'm going to call my backend GCS and put in URL. Now the URL is this. So pop that in here. Now I also need to put this same host name into my override host. And the reason for that is that if you make a request through Fastly to a backend and you don't modify it in any way, Fastly will actually present the same host header to the backend that the client presented to us. And that's likely not the host header that you want for the backend server. We use the host name to resolve the IP address, but if you want us to actually send the same host name as a host header, you need to tell us to do that separately. So we're going to do that by setting the override host. And that is a good idea in almost all cases. All right, now we can go into the main source file and have a look at what source code we started with. Now, it's pretty brief, and it is set up to initially respond to every request with a single predetermined response, which just says OK. So at this point, I'm actually just going to try this out. I can type fastly compute serve. That will build my project locally, start an instance of the local testing server, and it will give me a local address that I can use to view it. Also, you'll notice here in the output that because I've defined a backend called GCS, it will also helpfully check that that backend is up and available to use. Okay, so let's start with the new tab and go to that. And you can see we see OK. Okay, everyone can see that's very small, but it just says OK. That's a predefined response that you can see here. So the first thing I need to do is connect my Fastly service to my backend. And a simple way to do that is to use the fetch API. So we implement the fetch API. It's compliant with the way the fetch works in the browser. So I can take the request that has been passed in on the event, pass it into the fetch, and then fetch will quite happily send that request to the backend. I do, however, need to specify what backend I want to use using the same token that I created in my Fastly TOML file. And the reason that it's important that I specify the backend is because by statically defining backends on your Fastly service, we're able to do things like health checks. So we can determine whether your backends are up or down and react accordingly. You can also on Compute Edge define backends dynamically, so you can make requests to anywhere on the internet. But then you don't get any of those performance benefits or extra features that you get with statically defined backends. And also it can be a security risk if you accidentally create an open proxy. So this is generally speaking a good practice. And that is actually all we need to do to create a basic Fastly service that sends requests to a backend. So if I go back to my browser and reload, of course this won't work because I need to type fastly compute serve -- watch, which will restart the server every time I change a file, which I didn't do. So back to the browser and reload, and it worked. Doesn't look like it worked, but it did work. You're actually looking at error that's coming from Google Cloud Storage. It's telling us that it is not willing to enumerate the list of objects in this bucket, which is not a great thing to serve to end users, but it is technically working. And if I add /index.html to it, lo and behold, it now works. Cool. So let's see what happens if we deploy this to the edge. I'm going to stop my server and fight fastly compute. Wait. So it's identified immediately that my project is not already connected to a production service on the Fastly platform. Is asking if I want to create one. So I do. Yep, sure, I'll call it that. And now it's asking what domain I want to use. Now, we can accept the default domain, which is usually a good idea. You can always attach your own domain later. And now what backends do I want to define? So in the same way that I defined this for the local server, I'm also going to want to define the same backend on the production service. It is HTTPS. And I don't want to call it backend 1. I want to call it GCS because it has to have the same token that I'm using in my code to refer to it. It's now prompting me for a second backend. I don't want a second one, so I can just press enter to say I'm done adding backends. So this will create my service. It will create the domain. It will create the backend, attach all of those to the service, and then upload my WASM binary. Now, at this point, Fastly doesn't actually care that you originally wrote the code in JavaScript. We wrote the code in JavaScript on my laptop, and we compiled it on my laptop into WASM. And then what we upload to Fastly is the WASM binary, and that's what Fastly runs. So we're not natively preferring JavaScript. We're not running it under emulation. We're just running native WASM. We've activated the first version of the service, and so now what the CLI is doing is it's kind of helpfully trying to wait for that service to be deployed across the Fastly network, which is tens of thousands of machines, until it's available in the POP that my machine wants to connect to. And this can take a little while. Oh, it did. It worked. Okay, now this is expected. So it's telling me that the service path, the root path, responded with a non-successful status code. Check if this is what you expect. It is what I expect because actually the root path of this domain is going to give me that 403 response from GCS. And in fact, I can verify that by just going to this domain, which is helpfully given me right here. Let's open this in a new tab. And I get the same thing. So great. Let's start by solving that. So why does it do this? Well, it does this because you can't have an object in a bucket that doesn't have a name, right? So the root path of the website, you want to add /index.html or something like that to hit a real object that's actually in the bucket. Now, some bucket providers allow you to do this automatically. They'll build it into the platform, but I find it's quite useful to be able to do a lot of these kinds of things at the edge. So let's start with that. Okay, so back in my source code, I'm going to give myself a little bit of room for maneuver here by creating a shortcut to the request, which is event.request, and the URL of the request, which is rec.url. Now, it's very helpful to instantiate a URL class to manipulate the URL, because then you can use things like search params and you can extract the path name and so on. So what I want to do here, sorry, give me a second. So what I'm going to want to do here is check whether the path name of the URL ends with a slash. Now, what if it is the root path? Because if you look in the browser and you're making a request to the root of the website, it doesn't seem to have a slash. But in fact, your browser will be sending a slash for a root path request, and Fastly will always see one, at least one character in every path. So if the root path is requested, it will still end with a slash, as will any directory request, of course. So in this case, what we can do is just add index.html. Did I get that right? Yes, I think so. Okay, now I'm not running my local server at the moment, so let's just rerun that. Okay, so I'm rerunning this locally. Let's go back to the local version. And previously, when I was on the root path, this didn't work. And it still doesn't.
We love live demos.
Why doesn't this work, Alan?
Oh, you're not setting the
URL.
URL.
I'm not sending the right request here. What should I do here? I know what I'm going to do. I'm going to define a backend request to be a new request object. So again, web standard request class. I can pass in the URL I want on my new request, which is going to be rec URL.toString. It's not JSON string. There we go. And I can pass a second parameter to request, which is the existing request. And then I'll just inherit all of the other properties from that request. And then I'm going to fetch the backend request. Right. I have confidence that this will work now. Okay, it's rebuilt. Let's reload. And I think it's still starting out? Yeah. There we go. Homepage is now working. So we're still fetching the root path from Fastly, but Fastly is fetching /index.html from your bucket. So that's great, right up until you go to, and it will work also for subdirectories. So I can go into services. You can see it's also working here. Services / is not an object in my bucket. It is actually fetching services /index.html. But what if I go to just /services on its own? Okay, my browser is also completing that. That's not helpful. Let's do about. Okay. It's telling me there's no object called /about in the bucket. And that's because there isn't, right? It's /about /index.html. And we're not adding index.html here because it doesn't end in a slash. And we can't guess that we need to do this because about might actually be an object in your bucket. So the only thing we can really do here is to fetch that object, see if it exists. If it doesn't exist, then add /index.html and try again. And if we find an object then we could do an external redirect to tell the client to add the / and reload. So let's try doing that. So I'm going to start by assigning the result of this fetch to a variable, which I will call backend response, because we're going to need to be doing something with the response now. And I'll also define, I'll define a client response as well, which is initially equal to the backend response. But I'm going to make that a let because I might overwrite that later. So we want to say if the backend response is a 404 and the request URL doesn't end with a slash. Is that right? Yeah. So then, wait, path name, because rec URL is a URL object. We want the path name property of the URL. So if the path property of the URL doesn't end with a slash, and we got a 404, let's try adding /index.html and see if we can get an object. So I'm going to need another URL for this, which we will start off by copying the existing one, copying the request from the client, and then add index.html to the path name. Notice how before I was adding index.html, now I'm adding /index.html because we know in this scenario, the request did not come in with a trailing slash, so we need to add that too. So now we need a new request. Let's call this the test request, and we'll make it a new request, which is this, and then we'll try and send it. Test response, fetch the test request. We still need to specify on each of these fetches that we are using the GCS backend. Full typing information available for the SDK, by the way. So as I was typing backend, VS Code was able to suggest that as a valid property. And I need to wait that. Okay, so I was going to complain about that for a second. So now if the test response status is 200, then we know that we initially had a 404. for an object that didn't end in a slash. We added slash index.html. Now we have an object that exists. So instead of serving that object to the user, we really want to tell the user to redirect and add a slash, because otherwise we're going to be serving exactly the same content on two distinct URLs. So the correct thing to do here is to redefine the response. Now we can do this with the response constructor. You might remember that when I opened this file initially, the only thing in the file was a thing that said return new response 200 OK. So we're going to use that same constructor here to create a redirect response. Redirect responses do not have a body, so the body is null. And then I can say status 301, and I need to provide headers, specifically a location header, which will be rec URL dot path name plus a slash. I think technically I should be including the domain as well. I don't know whether you know whether that's in the spec or not, Kaylin, for the location header, but it always seems to work if you don't include one.
I'm actually not entirely sure, but it does seem to work.
It does seem to work. Okay, so we've constructed a new response, and yeah, if we choose not to construct a response, then it will just fall through and be the response that we got from the back end, which is great. So I think that should work. Okay, result. Let's give it a go. It's taking a while to check that my GCS backend is up for some reason. It was a lot faster in rehearsal. There we are. Error 500, what's going on? Okay, so this is a good opportunity, almost as if I planned it, to explain what happens when you get a runtime error in JavaScript. So it's saying promise rejected but never handled, respond with must be called with a response. So I'm returning from a handle request with something that's not a response. And of course, the problem here is that I forgot to, because I'm an idiot, forgot to return response at the end of this function. Okay, I've done it now. So previously I was returning like the return value from fetch, which would be a response object. When I then decided to assign that to a variable, I then needed to explicitly return a response object, which I didn't do. So that's why it was returning undefined and causing runtime error. Pretty helpful runtime error though, so that was okay. Now we're just waiting, there we go, the backend to be checked, and let's try again. Okay, interesting. So we're back to the previous behavior. I can respond status 44 and not URL path name ends with a slash. Yes, I think that's right. I'm just checking where I did this earlier. Okay. Looks right. No, I don't work again.
Can you scroll down slightly to where you do return the response? Yeah.
Redefine the response here to be a, well, let's debug it. So if I throw in a console log statement and say trying for directory, and let's name string. Well, should work. Test request and fetch test request. That comes right. Okay. So I save that then. Another opportunity to explain that if you type anything into your code that produces output to standard out, however you do that in the language of your choice, in JavaScript, it's obviously console.log, then our local testing server will intercept that output and just display it in the terminal. So once this restarts, I should be able to reload and see whether I actually ended up going through these code paths or not. Looks like I didn't. Okay, so did I get a 404? So yeah, I did get a 404. I know what I've done wrong. I didn't await the response.
Ah, of course.
So what happened there was I didn't await the response. So backend response was actually a promise. So, you know, a promise won't have a status property. So, you know, we never actually got into this, this code block here. So I'm pretty sure this is going to work now.
I think the beauty of doing this live is that we get to make mistakes like that and show people how to resolve them, because it's very easy to do that.
Yeah, absolutely. Okay, so let's try again. Hooray. Okay, cool. So we made a request for /about, as you can see here in my terminal, which my inspector, which I very conveniently still have open, almost as if I planned it. You've got a request for /about that has resulted in a 301 response and a location header, and then the redirected request to about / which has succeeded. And that's also only succeeded because we then added the index.html because we've detected that the URL ends in a /. Cool. Okay, pretty good so far. What am I doing next? Errors. So we've fixed a bunch of errors. Like, you know, there's situations where you would get one of those horrible XML errors from Google and you won't anymore. You'll get the page that you wanted. But what if you go to a page that clearly doesn't exist? You're still going to get this XML no such key error. So we want to fix that. Now, our bucket happens to contain a file that we want to serve in the event of a 404.
Would you like me to remind you of the path?
Remind me of where that is.
Yeah, it is at /not_found.
Oh, there we go.
/index.
I've
There
been
you
there
go.
before, apparently. Okay, so there we go. That's the URL of our not found page, and this is what it should look like. But it currently obviously looks like this. So let's fix that. All right, so we want to do this after this this stuff we did before, because of course this is dealing with a 404 situation. So let's go down here, and this time I want to use the RESP status because I really am dealing with this as something that I want to apply to the client response, kind of irrespective of what happened with the backend. So if, for example, you had a service that was actually using multiple backends for different paths, then this is better, something you're better off doing with the client response because it's something that you're likely to want to apply to all responses regardless of what backend they come from. So we'll say if response status is still 404 at this point, then very much like this, we're going to want to construct a new fetch. And yeah, let's just copy this fetch line here. Say, okay, so this is an error response, or it really is an error content response, I suppose. Await fetch, and then I don't have that on my clipboard anymore, do I? Okay, now I do. Cool. Now I could keep this host name here exactly as it is. I actually, just to remind myself that the host name is being overridden when we send the request to the backend, I like to just set it to backend because the host name override that we applied in the fastly.toml file, this override host will take care of that. It also means if we change the backend later, we don't need to go through our code like changing all of those URLs. All right, so that's my error content response. I've remembered to await it this time. And so now we can say if the error content response status is 200. Now, it's not going to be a 404 because, of course, it's actually an object that exists in the bucket. So we're going to get a 200 response. But what we want to do with that 200 response is to construct a new client response using the response constructor. Oops. Response, okay, and use the content stream from the error content response. Now notice that I'm not actually awaiting that streamed content. I awaited the fetch, which means the error content response will get populated when we've received the header portion of the response from the backend, but we're not waiting for the backend to send the whole body. And we're certainly not reading the whole body into our computer edge program. It's really important that we don't do this, because every time you read a whole response into memory, you're buffering it. And you know, the reason that edge compute is such a great thing to use is because it can give you really amazing performance with the interactions you make with the end user. So anything you do that suddenly buffers like a huge file from the back end is a really bad idea. So we'll take the content response.body, which is a stream, and pass that as the content to the response constructor. And then we need some metadata. Specifically, we need a status, which we will set to 404. Do we do anything else? Oh, we need to copy the headers. So the headers will be the same headers that we got from the backend response. You could construct new headers if you wanted to, and we'll actually get onto that in a second. But for now, we'll just copy the headers that we got from the backend. And I think that should do it. So
the last, oh no, you have assigned it. Perfect.
I don't imagine I've got it right, but let's try.
There's only one way to find out.
Okay, so we're back inside. Let's try, so which tab do I want? This is my local one. Yeah, so this is my error response from GCS. If I reload, interesting. Oh, I know why this is. Do you know why this is?
I'm guessing that Google is giving us some cross-origin response headers that we don't want.
I think it's because it's giving us a content type of text HTML, text XML.
Of course.
So I think instead of using the headers from origin, I'm going to manually set the content type to text HTML. Or in fact, what I could do is, instead of using the headers from the original backend response, I could use the headers from the error content response.
I think that's reasonable.
That's probably what I should do. Let's do that. If I was just to set a content type, that would be a little bit of a hack, really. No content length or anything. It's not good news. And okay, Jesus, reload. Hooray! Okay, so now we have a 404 page, and this will get served automatically by Fastly if you ever encounter a situation where you're requesting an object from the bucket and it's not there. Okay, so next thing I want to do is look at the headers that we're getting from the server when we get this 404 page. So you can see that we've got some cache control instructions on here, and we've also got a whole load of stuff from Google, which they're adding just because we fetched an object from a GCS bucket, and all of these headers got passed through by Fastly. This isn't great, honestly. This is revealing a lot of information about the backend technologies that we're using. And there's a few other things we probably want to change in here as well. So before we get to that, I want to deploy this to the edge again. So I'll stop my server and do Fastly compute publish. Since I'm running the local testing server, it will already have built the latest version of my code. So I probably could have just typed Fastly compute deploy, but the build step takes a lot less time than deploy, so it really doesn't make much difference. Big difference, though, in this case, is that it hasn't prompted me for any information. The first time we ran Fastly compute deploy, it said, do you want to create a new service? And, you know, what domain you want, what backend do you want? And this time it hasn't asked any questions at all. It's just gone ahead and deployed it. And the reason for that, if I go back over to the Fastly toml file, is that the Fastly toml file now has a service ID in it. And the CLI has actually added that service ID into that file. the first time we did the deploy, and it knows now that because there's a service ID in there, that it just needs to publish to an existing service. Okay, so we have deployed a new version of the app, and I have it here somewhere, right? Yes, there. So in theory, this takes rather longer than refreshing the local server because we have to deploy it to literally tens of thousands of servers all over the world. And I have to wait for it to reach the one that I happen to be connected to, which is probably our local POP in London. But the reason I want to deploy this to the edge now is to talk about caching. Because when we run the local testing server and we see the effect of loading pages through that, it is running our code, but it will never actually cache anything because it doesn't have a cache attached to it. So when we deploy to production, we can start using the Fastly Edge cache, which will be transparently just part of our service automatically. Anytime you make a fetch to a backend, if that backend attaches cache freshness metadata like a cache control header or an expires header, we will just automatically cache it to give you like a good default behavior. And I've been talking long enough for that to now work. It's great. It's almost like I'm a TV presenter. So now if I go to inspect this and look at the network, the reload, the response headers now include an X cache response header, which says hit. So that means that this response actually hasn't come from GCS at all. It's being served entirely from Fastly and is coming straight off of our edge cache. If I go to a page that I haven't visited yet, like in production, and I look at the response headers here, X cache says miss. If I reload it again, it says hit, and that's pretty reliable. Like I wasn't under any doubt that would happen, because basically anything you load through Fastly that is cacheable, we will cache it, and we may well evict it before its TTL expires if we've got other stuff we need to store, but we will store things pretty much guaranteed the very first time that we see them. Okay, so that behavior is pretty good. What I don't like though is that we have all of this stuff that's being added by Google, and you know, this is not great to leak out of your service, right? You know, this could give useful information to some kind of bad actor that wants to attack your site, and it's also just detritus that is going to get in the way if you ever want to try and debug a problem. It's distracting. So there's a couple of different ways we can go about managing the headers that we release from our edge service to the client. I'm going to present both of them because there are arguments kind of for and against either one. So the first thing I want to do is operate a block list effectively. So I'm going to create a constant up here, top of my file, for response headers strip prefixes. That'll do. And I want to strip anything that starts with xgoog, and also, kind of annoyingly, they also use another prefix, which is g uploader. Could it have started with xgoog, I wonder? Any users watching?
Shots fired.
Okay, so REST headers, string prefixes. So let's filter these out. So we want to do a for loop, and we'll get the keys from the response headers. Now, response headers is a map, so we can get keys from it, which will give us an iterator, and using the iterator in a for of will give us each value of that iterator sequentially. And this is a really great pattern to use for everything on Fastly, because it's really it's compatible with any kind of streaming data source as well. So get into the habit of doing that rather than like spreading arrays and that kind of thing. So we're going to look at each of the keys in our headers collection, and then basically just say if that header starts with, if the header starts with any of these prefixes, how am I going to do that? So I guess I will use a sum. So this will give me a prefix, and then I can do k dot starts with that prefix. So if that's true, then I want to headers.delete. Okay. So I'm basically saying if for each header, if the header starts with my bad prefixes list, delete the header. All right, and I'm going to just rerun that locally because it's quicker. And we can try it out. Now, we won't see all the same headers locally that we see in production because we won't see things like Xcache, for example, but we will see all of that additional Google metadata that we can work with. So, cool. So just have a look again at the kind of metadata we're seeing there. That's in production. Hold on. That's my local one. It's an error response, but same thing applies. We still have all of this Google stuff. So I'll reload this. And lo and behold, we don't have any xgoog or xguploader response headers anymore. Great. It also means that if later on your origin backend is adding more response headers, then they will just flow through the Fastly layer automatically because we're not banning new things. We're just saying anything that we recognize as being metadata that we want to remove, we're removing. Everything else we allow through. And this is a good way of countering a principle called ossification of the web, which is where basically things that have lots of possibilities and can be defined very broadly are typically used in quite a narrow way. And then people start assuming that that narrow way of using it is the only way anyone ever uses it. And then they build systems that are only compatible with that narrow way of using it. Or people simply build systems that are just bake in, are hard-coded the way things work today in the expectation that they'll never change. And if you have an email address with an uncommon domain ending or one of those new domains, like .shop or something, and you've tried to fill in the form which has told you your email address is invalid, then you've experienced ossification of technology. Basically, it becomes harder to change things because people bake stuff in. Fun fact is that in the UK, the rate of sales tax was 17.5% for so long that it got baked into software all over the place. And when it finally changed, it costs tens of millions to fix. So it's bad, don't do that. But on the other hand, it's also bad to pass response headers through from your origin to your client completely unfiltered. And a good example of that is the alt service header. And also, in fact, any kind of response header that advertises a capability of the server, because the capabilities of the backend are not going to be the same as the capabilities of Fastly. Fastly may offer more capabilities, or the match may not be perfect. So in this case, for example, this request on my local system is being sent over HTTP 1.1 because that's the version of HTTP supported by our testing server. But if I look at the production site that we deployed, this one is being requested over H3, the newest version of HTTP, which is fully supported by Fastly, and we use it as much as we can to try to give people the very best performance. But in order to upgrade a client to H3, you need to verify that the client is capable and also that the server offers H3 as an option. So the client will initially connect using usually HTTP 1.1, and the server has to advertise the ability to connect over H3, which we are doing because we have this response header that says alt service. But that's not being served by Fastly, that's being served by Google. Because if we look at the object directly in the bucket, and we see the network tab for that, you can see that that alt service header is being passed through from Google, and Fastly is just replaying it to the client. And then the client is saying, oh, okay, you support H3, I'll connect using that. Now that happens to work because both GCP and Fastly both support HTTP3, but this is not a solution which is I don't know, reliable, I guess. It's fragile. It works by chance, not by intention. So let's make it work by intention. And we can do that by being much more deliberate about the headers that we allow from the back end. So ideally, we want to allow from the back end only the headers that describe the content, not the capabilities of the server serving them. And then we would explicitly pass on to the client any headers that describe the capabilities of the server, because we are the server at the edge. So instead of doing strip prefixes, I'm going to do the opposite and say response headers. What am I going to call this? Allowed response headers, I guess. And these are going to be explicit. It's just going to be an explicit list, not a list of prefixes. So to figure out what I want to use, I'm going to go and have a look at the page as served by Google directly and look at the response headers that they attach. So first of all, accept ranges. That's a server capability. I don't want to pass that on. Age, I do want to pass that on. That's a property of the content. Alt service, don't want to pass that on. Cache control, do want to pass that on. Oh, I need to be writing these down. So age, we want to allow. Cache control, we want to allow. Content length, of course, content type, date, e tag. These are all good stuff. So we will include all of those: content length, content type. Incidentally, if you don't include a content length in your response, if you construct it, for example, inside of a computer edge service, we will try and add a content length if we can determine what it is. Sometimes we can't if it's a stream, for example, so in which case your response will go out without content length. I distracted myself. Date, yes. Dates are required part of HTTP metadata, so we always allow that. E tag, so E tag's good. Both the E tag and the last modified header, those are examples of request validators. So if the response has one of these request validators attached to it, it enables Fastly to make a revalidation request, a conditional get, to basically say to the origin, has this content changed? If it hasn't, it can serve a 304 not modified, and we can just refresh the content we already have in the cache. Makes for a very efficient cache management. So we like that. We should keep E tag and we should keep last modified as well. We should also spell last modified. Okay, I skipped over expires. Now I'm going to not take expires, because expires and cache control are both expressions of cache freshness, and cache control is a better one. If your content includes both a cache control header and an expires header, Fastly will prefer the cache control header and will ignore the expires header. And we generally speaking want downstream caches to do the same. So we will remove the expires header, knowing that this particular backend does include cache control as well. Now, you could be more intelligent about this. You could say only remove the expires header if the cache control header is not present. But in this case, we know that we'll always get a cache control from Google. Server is just advertising, basically, so we don't really need that. It's also set to this bizarre phrase, upload server. I don't know whether that's specific to GCP or whether other web servers call themselves upload server, but we don't really need it. Fastly, incidentally, does not add a server header to responses that go through us. So if you don't serve it from the back end, it won't be present on the client response. Feel free to write server Fastly if you like. We're very happy with that. We're obviously going to skip over all of this Google metadata, and that's it. Okay, so actually I'm done. I think these are all of the headers that I need. So allowed response headers. Okay, so let's take this existing implementation and comment it out and try something new. So similarly to before, I want to enumerate all of my response headers. Headers, keys. Oops. Okay, but this time I want to say if the allowed response headers array doesn't include the key, then delete it. Is that right?
That looks correct.
That's right. Cool. So how are we doing for time, Kevin? Are we over time already?
We're fine. We've got another 10 minutes.
Right. So we should be able to demo this on the local version. If I just look at the headers I was serving before. So we've removed the XGOOG stuff. We should see except ranges and alt service disappear here. So let's just make sure this is up. Yeah, and try that. Great. Okay, it's nice and clean. So these response headers are the ones that we are willing to serve from the backend. So the last thing I'm going to do here is to add more headers, things that metadata I want to add to the response at the edge. And so for this, I can just very, very easily just do rest.headers.set and then just add whatever headers I want. So for example, I would always recommend that you include strict transport security header in the response. I'm just trying to remember what the correct syntax for this is. No, hold on a second. I don't have it here. I'm just going to do it live.
Just Google it.
HSTS header example. Good old MDN. Well done. Is it going to give me something I can? Yes, it is going to give me something I copy and paste. Love it. Okay, so we could do, yeah, let's do combined. All right. And this basically says to clients that are using your site that they should always connect over HTTPS from now on. If they did connect over insecure HTTP originally and got redirected to the secure site, don't do that again. Just come straight to HTTPS next time, even if the user seems to want to connect to HTTP. Other things we could add here would be like a content security policy. I'm not going to do that now because trying to write a content security policy by hand is slightly beyond the scope of 8 minutes of live stream, I think. But we can also add some additional metadata, like we could add a clause policy, for example. So if, for example, you wanted anyone to access your static assets cross-domain, then you could add an access control allow origin header. You might want to make this consult and allow list of origins that you're allowing to make cross-domain requests to your site. If you're fronting a static object store, then usually having a pretty permissive policy on cross-domain requests is pretty safe. So adding these headers allows us to be quite opinionated about how clients interact with our service. And another thing we could do actually at this point would be to add back in that alt service header. And so now we're quite deliberately advertising that Fastly supports H3 rather than just taking it for granted that the backend will do it for us. I've forgotten how to write that. And an example of this is, there we go. That's basically the canonical alt service header for
Actually, H2.
That
should work.
Not canonical breakthrough at all. But there you go. That should do that. So if I run this again, and we'll make this the last thing we do. We can load it locally and we'll see that these headers get added into the response. Other things you could do with headers, by the way, we don't have time to go through it today, but for example, it would be a great idea to filter the request headers to remove headers that we don't want to pass on to the origin. So for example, if you're working with untrusted origins, let's say you're passing requests through to a third party, or GCS is a good example of a third party that doesn't need necessarily to see the authentication data that we're working with the client, then you might want to remove the cookie header before you send the before you forward the request to the back end. You may want to add an authentication header to your request. If we're using a public bucket here, but if you were using a private bucket, you could calculate the required signature at the edge, attach it to a a request header, and then you would be able to authenticate with Google Cloud Platform or AWS or whichever bucket service you're using. And if we go back and try this again, we should now see, so we now have our strict transport security header. We have our alt service header back, but we're now being intentional about it, saying like this is definitely supported by this server and not just the one that we were talking to as a backend. I don't know why I'm using the 404 as an example of all of these pages. There we go. There's a Verda page. It's the home page, and we have automatic loading of directory indexes. We're redirecting people to directories if they don't add the trading slash. We're using custom error pages, and of course, you could also have custom error pages for 403s or other kinds of errors. We are cleaning up HTTP metadata from the origin, and we're also adding some best practice security and performance headers. You could also add link preload or even early hints to the response that you generate at the edge. Lots of other things you can do to enhance the ability to serve static content through Fastly. This has been a bit of a taster, but I think I'm out of time.
Thank you so much, Andrew. That was incredibly useful, and I'm sure that this will be a great resource for people to come for many months. If you've enjoyed watching this, then please, by all means, subscribe to the channel. We're going to do one of these every month. We'd love to teach you all about Computer Edge and Fastly in general. And if you have any specific things that you'd like to see us do, then tweet us at Fastly Devs or send some feedback on the form on the Developer Hub at fastly.dev. We'd love to see you here again next time. Again, thank you, Andrew, and everyone, take care. Have a fantastic week.